matrix matching. In column 1 we have binding energy of helium ion in an excited state, and if the electron transition is from 7th to 3rd in hydrogen atom, 5th to 1 transition in hydrogen atom, series limit of Balmer series in hydrogen atom. These are the 4 A, B, C, D that are given in column 1. Then what about column 2? We have infrared region, 3.4 electron volts, 13.6 electron volts, 10 spectral lines, and 1.9 electron volts. So we need to match A, B, C, D with PQRST options given in column 2. So let us take option A, binding energy of helium ion. And the binding energy of helium ion is given by what? 13.6 into Z square, and we have to take by N square because it is the binding energy. Binding energy of helium ion in an excited state is mentioned. So therefore N is equal to excited state. We need to go for 2, 3, 4 and so on. And Z for helium ion is nothing but 2. So when we substitute, we get the binding energy of helium ion in various excited state. Case 1, if N is equal to 2 and Z is anyway 2. So thereby when N is equal to 2, Z is equal to 2. Since we have Z square by N square, this gets cancelled and we get binding energy as 13.6 electron volts. So we have for A option 13.6 electron volts. So R will be coming out as one of the options. Similarly, when we put N is equal to 3, Z is equal to 2. If N is equal to 3 and Z is equal to 2, what do we get? Binding energy of helium ion in second excited state is given by 13.6 into Z square, that is 4 by 9. So this is about 1.5 into 4, around 6 electron volts, where we do not have this option. So thereby this is not there among the options given, and thereby it is wrong. Then what about N is equal to 4 and Z is equal to 2? Then the binding energy of helium ion comes out to be 13.6 into 4 by N is equal to 4, 16, 1/4 of 13.6. So 4 3s are 12, 3.4 electron volts. And we have this 3.4 electron volts as the Q as the option. So thereby we can select Q also. So for A option we have 13.6, which is nothing but R, 3.4, which is nothing but Q. So Q and R are the options. Therefore A goes with Q and R. Now let us take B. What is B? If the transition of an electron is from 7th to 3rd transition state in hydrogen, how many spectral lines will be formed? So when the transition is 7 to 3, the electron is coming down to the 3rd level. So therefore N is equal to 1, N is equal to 2, N is equal to 3, N is equal to 4 and so on. And it is finally coming down from 7th to 3rd. So this spectral line will be in the infrared region. And also the delta N, 7 minus 3, that is 4. So thereby there will be sigma delta N number of spectral lines. That is 4 plus 3 plus 2 plus 1. Therefore 10 spectral lines will be there. So thus infrared region 10 spectral lines. Infrared region is P, 10 spectral line is S. So thereby the answer goes with P and S. So B goes with P, S. Then what about C? C is a similar type of question. 5th to 1 transition in hydrogen atom. So when the transition is 5th to 1, the spectral line will be in the Lyman series, that is UV region. Since the transition is from the 5th to 1st orbit, delta N is 4. Therefore the total number of spectral lines as above is nothing but 10. So let us see the options. Ultraviolet region, 10 spectral lines. So we have ultraviolet region is not there, 10 spectral lines is there. So S is the option. Therefore C goes with S. Then what about D option? D option corresponds to series limit of Balmer series in hydrogen atom. We are asked to find series limit for Balmer series, that too in hydrogen atom. So in Balmer series we have N1 is equal to 2, and to have lowest wavelength N2 should be infinity. For smallest one N1 is 2 and N2 should be 3. So with this values where we have the energy E given by 13.6 into Z square hydrogen atom. So 1 into, if we take the second case, we will have 1 by 2 square minus 1 by 3 square. And if you take the second case, 13.6 into 1 into 1 by 2 square minus 1 by infinity square, nothing but 0. So therefore, these two corresponds to, and this further can be written as 13.6 into 5 by 36, and whereas this will come out to be 13.6 into 1 by 4. So thus the respective values are 1.9 electron volts and 3.4 electron volts. So do we have 1.9 and 3.4? So here we have 3.4 Q and 1.9 T. QT will become the answer. So D goes with QT. So this is how we need to work out matrix match type of question.